Hello everyone, I am Dr. Fawzul Atik. I am giving some series of lecture for the course Discrete Mathematics. So in the previous lectures, we discussed about the quantifiers, right? Quantification. And then we also discussed about nested quantifiers and then how to negate the quantifiers, right? Nested quantifiers. So these things we have discussed. So in today's lecture, we will discuss about the rules of inference. So what is that? Let us see. We need to know some terminology. So first, let us just know in the name of definition, and then we'll understand them clearly once we will deal with the examples. So an argument in a propositional logic is a sequence of proposition. So some proposition will be there. So it is some sequence of proposition will be there. You call them as an argument. Then all except the final proposition in the argument are called premises, and the final proposition is called the conclusion. I'll show you example. And then an argument is valid if the truth value of all its premises implies the conclusion is true. And argument form in a propositional logic, is a sequence of compound proposition involving propositional variable. So this is called an argument form. And then it is like that. So suppose I have some sequence of proposition, it is like that, P1, P2, and Pn. These are some proposition and Q. This is some sequence of proposition. This kind of thing you called it as the argument or argument form if each of them are compound proposition involving some variable. Now all of them except the last one you call them as premises, and this one you called it as a conclusion. Right now this is an argument form, and you said that this is a valid argument form if this quantity is a tautology. If P1 and P2 and dot 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 up to Pn, all of them together imply Q, it is a tautology. So if you can prove that this is a true statement, you call them as this argument form is a valid statement. Now again, these are again for the sake of that you should know the definition and all, but you will understand clearly once you will deal with the example. And then you want to prove that an argument form is valid, so therefore you will prove that this kind of thing is a tautology. Therefore you will prove that this is true always without depending on the truth values of P1, P2, Pn. So therefore how we will do that? You can do it using a truth table, correct, or some logical equivalence formula we know already. You can do that way. So this can be a big one also, right? So what we can do, we can do that we will previously solve a small argument form, and we'll show that they are valid, and then we'll treat them as a formula to prove a big argument form is a valid or not, right? So these small which are relatively small or simple argument form are called the rules of inference. And you will see that you will understand each of the rules of inference by applying your common sense only. You can easily prove it by truth table or any other method, but you can understand them, okay, this will happen just by applying your common sense. The first rules of inference, the first one, which is a very easy one. So if you have P and if you have P imply Q, therefore it is Q, right? So suppose I have a proposition P, then I have a proposition P imply Q. Then what is the conclusion? Now you know, suppose you can see that, okay, like look at this example. If it snows today, then we'll go for skiing. It is given, also it is given as it is snowing today. Then what will be your conclusion? You'll go for skiing, right? Or you may see that, okay, if you studied regularly, then you will get good score in discrete math. And this is a statement which is true, that if you studied regularly, then you will get good score in discrete math. This is one. And next is you studied regularly. What will be the conclusion? Yes, your conclusion will be you will get good score in discrete math. It is like that. You have P and you said that P imply Q. So both of them together, what will be the conclusion? This is Q. Right? So this is one of the rules of inference. So therefore this and this together, so P and P imply Q. Both of them are there. So this to imply Q is a tautology. You can also prove it using truth table that okay, you will get this is a tautology. So this simple formula you call it as a modus ponens. Modus ponens, the first rules of inference. And then you have this example that we have already discussed. If it snows today, then we will go skiing. And its hypothesis is it is snowing today, then what will come as a conclusion? We will go skiing, right? Yes, so the conclusion will be we will go for skiing. It will be true. Now, this is the first rules of inference, and then we have seen that it is very easy to understand. I'll discuss few more. So the first one I'll write down that P, and then P imply Q, therefore Q. This is the first one. Then we'll have few more. I'll show you, and then you think of it, and you tell me that what could be the conclusion of it. I have not Q, and I said that P imply Q. Who will say that what is the conclusion from there? Again, you just understand the example. If you studied regularly, then you will get good score in discrete maths. This is one statement. And then I'm saying that you did not get good score in discrete maths. What does it mean? I'm saying again, if you study regularly, then you will get good score in discrete maths. And you are seeing that you did not get good score in discrete maths. What does it mean? That means you have not studied regularly, right? So you understand this rule with this example. You have not Q, and you said that P imply Q. What does it mean? So you have P imply Q, not Q, and you said P imply Q. Therefore, P must not have happened. So therefore, it is not of P. You can also understand this in this way, because the contrapositive of this is what? Not Q imply not P. And then you have not Q, and then you are saying not Q imply not P. So by the first rule, you can say also that this conclusion will become not P. So it is validated. We understood. So this is the second rule. Okay, my third rule. You apply your common sense, you will get what could be the conclusion. Suppose I have P imply Q and I have Q imply R. This is very easy. What is the conclusion from there? P imply Q, and you are saying Q imply R. Therefore, the conclusion will be P imply R. Right? So these are all of them have some name. So I'll show you in the next slide that what are the name of all these things. So, but you can see that you can easily understand that what will become the conclusion just by applying your common sense. And you can also verify them by using truth table and logical equivalences formula. Okay, I'll show you one more. I said that P or Q. Then I'm saying not of P. Can you tell me what will be the conclusion? You said P or Q. Then you are saying not P. Then who? Yes, it is Q then. So this is another rules of inference. I said P or Q, then not P. Therefore who? It is Q. I am saying either Sai Krishna or Ramcharan. Then I am saying not Ramcharan. Then who is that? It is Sai Krishna. It is like that. So P or Q, not P. Therefore it is Q. Okay, then next is 5. I have, okay, this I can easily also understand that I have a proposition P. I can easily say that P or Q. I can add one more variable into it. Because I know already P will contribute here. So I can certainly say that that P is there, therefore P or Q will be always true. Okay, so this is an addition. This rules of inference is known as an addition because you added one more proposition into it. Okay, number 6. It is I have P and Q. Then I can individually say, I am saying that Shai Kiran and Ramcharan. Can't I say individually for Sai Kiran? I can say, I could have said Q also. Right? So this from this I can say that P and Q I have. I can say it is P. I could have said Q as well because they are commutative, we can apply the same rule. So this is called a simplification. You had a compound proposition, you made it a proposition, only single variable, right? So it's a simplification. Okay, number 7. I have P, I have Q. Know that, okay, it is true for Sai Kiran, it is true for Ram Charan. Can't I say that P and Q? Yes, I can say it is P and Q. Because P and Q are individually there, therefore I can join them as P and Q. Okay, so number 8, the last rule of inference. It is P or Q I have, and then I have not P or R. What will be the conclusion? So it is P or Q, then you are saying not P or R. Therefore, what is the conclusion? Yes, it is Q or R, right? So here this P or Q, you are saying P or Q, and then you are saying not P or R. Therefore, what is the conclusion? Q or R, right? So this P is getting resolved. This principle is known as resolution. This is known as resolution. So this is a addition. This is simplification. This is conjunction. We already know. This is a resolution. This is modus ponens, right? And this is modus tollens. I'll show you in the next thing. Then hypothetical syllogism. So this one, I'll show you the names. Yeah, so look at this. We already discussed. So this is the rules of inference, and this will be a tautology. This is just a how to write it, represent it. Okay, you will see that this will be always true equivalent to T. So all the rules are there. So you may not remember the name. That's okay, but you should remember and understand each of the formula. You should remember and understand each of the formula, which is very easy to verify and is very easy to remember also, because by common sense you can see that okay, this will happen. Now few example. It is below freezing and raining now, therefore it is below freezing now. Now can you see that? Okay, which kind of rules of inference you have applied? It is below freezing and raining now, so it is P and Q type, right? And therefore it is below freezing now, so therefore it is P. It is like that, right? It is a simplification one. It is this rule. Okay, what is the next example? This one we already discussed. What about this one? It is below freezing now, therefore it is either below freezing or raining now. What you have applied? Yes, you have this single one, and then you said that therefore it is either below freezing or raining now. So therefore P or Q. So it is first it was P, then you made it as P or Q. Right? So addition one. Yeah, like that. Next, if it rains today, then we will not have a barbecue today. If you do not have a barbecue today, then we'll have a barbecue tomorrow. Therefore, if it rains today, we'll have a barbecue tomorrow. So how do you interpret this? Which rules of inference we have applied? So suppose I have the if it rains today. So if P, then we'll not have a barbecue today, right? So not have a barbecue today, I will apply it like this. And if you do not have a barbecue today, so this is Q, I already denoted, and then we'll have a barbecue tomorrow. This is R. And finally, if it rains today, then we'll have a barbecue tomorrow. So it is like that. Now, so I have P imply Q, then you are saying Q imply R, and therefore it is P imply R type. Rule number 3. Correct? These things we should understand that okay, this is happening, and then we'll apply into a big little bit complicated, little bigger argument form, and we'll show that they are valid. Our first example is this. So that the following hypothesis says P imply Q, not P imply R, and R imply S lead to the conclusion Q imply not Q imply S. How do you do that? Right, so we have 3 premises here, and we have to show that these 3 premises gives the conclusion as Q imply S. So what is premises? I'll write down that 1, P imply Q. This is number 1. Number 2 is not P implies R. Number 3 is R imply S. These three are given. So I'm denoting them by P. P means premises. These are given. Hypothesis. What you have to show? You have to prove that the conclusion as not Q imply S. You have to show that this is the conclusion from this three. So how do you do that? See, you need to get not Q imply S. So this S imply S things is there in 3. Somehow I have to involve not Q in the beginning. So what we will do? I will try to omit the variables, right? So if I apply 2 and 3 together and some rule, what I will get 2 and 3 by 2 and 3, what I can say? Just look at it carefully. Yes, we'll get not P imply S by rule number 3, right? So how I got it? By rule number 3 applying to 2 and 3. So these two proposition we have applied rule number 3. So 2 and 3. So I got not P implies. So this is done. Now I need somehow this not P should be replaced by not Q. So Q is involved in 1. So something I have to do so that I will get something that I can replace not P. Okay, but I know the contrapositive of 1, right? We know that, okay, P imply Q is equivalent to its contrapositive. So what is that? So therefore 5, I will say that it is Q, not Q imply not P. What is, how do I get? It is from 1, right? That contrapositive of 1. So by 1 I got it. Not Q imply not P by contrapositive of 1. And I think now you already see the answer. Now if I apply 4 and 5 together, what you will get? You have not Q imply not P, and then you have not P imply S. So if you apply 4 and 5 together, and if you apply rule number 3 into it, what you will get? Definitely you will get not Q imply S. That is our M. How do I got? By number 4 and 5 and rule number and some rules of inference. Right? So always try to write the reason how you got it, so that you will not have any confusion, and it will be like complete answer is like that. You should write the reason how you got it, and you got this is as a conclusion. This is what we want to show. I hope this is easy and clear. Yeah, this is the complete answer. You can see with all the reason is also given that which rule you have applied. Okay, I have a new one. Look at that. So that the premise is, if it is not sunny this afternoon and it is colder than yesterday, then we'll go swimming only if it is sunny. If you do not go swimming, then we'll take a Vizag trip. And if you take a Vizag trip, then we'll be home by sunset. Lead to the conclusion that we will be home by sunset. So we have to solve this one. So because you have so many compound proposition and they are also in English sentences, right? So to get the conclusion, you have to apply so many rules, and to deal with that, you should represent each of the sentences by some variable, so that it will be easy for you to deal with, right? So what is I am giving you, I am helping you to give to represent this English sentence. So the first job is you represent them by some propositional variable, all these English sentences by propositional variable. So suppose S is it is sunny this afternoon, then C is it is colder than yesterday, W is we will go swimming, V is we will take a Vizag trip, H is we will be home by sunset. So if you denote it in this way, then you read the statement and you tell me what is given. It is not sunny this afternoon and it is colder than yesterday. What does it mean? It is not sunny this afternoon, and so not S is it is sunny this afternoon. So the premises is given as number 1 is given as it is not sunny this afternoon, so not S, and it is colder than yesterday, so not S and C. This is the first premises. Number 2, what is given? That we will go swimming only if it is sunny. We will go swimming only if it is sunny. What it is given? So it is not if it is sunny, it is only if it is sunny. So all of you should remember that when we do the conditional statement, we have told, right, that some terminology you can write for P imply Q. So it is if we go swimming, we will go swimming only if it is sunny. It actually means that it is we will go swimming imply it is sunny. So that means W imply S. So this is the implication. This is the another way of telling that P imply Q. So it is given. Okay, the next one. If you do not go swimming, then we'll take a Vizag trip. It is written as if we do not go swimming, then we'll take a Vizag trip. How do you represent? If you do not go means not of W. So it is given as not of W, and this is imply we will take a Vizag trip. Therefore, it is not of W imply V. This is another premises. Then number 4, if you take a Vizag trip, then we'll be home by sunset. If you take a Vizag trip, then we'll be home by sunset. It means what? It is V imply H. So these 4 are given as a premises. And then what is your conclusion? Your conclusion is we will be home by sunset. So you have to prove that your conclusion is home by sunset means you have to extract H from this. So how do you do that? Now this is these 4 are given with the help of rules of inference and some logical equivalences. You have to prove that you will get the conclusion as H. So you can easily do that just by omitting the variable and what is needed that you should have. So number 4, H is involved. So you have to somehow extract H from number 4. So try to simplify, try to omit the variable wherever possible. So I can see that if I apply number 3 and 4 together, I can see that I will write it as not W imply H. How I got? By number 3 and 4 and rules of inference 3. I applied and I got it. So I have not W imply H. Then what to do? Now I have number 2. Right, so number 2 I have, and if I apply its contrapositive, because the conditional statement is equivalent to its contrapositive, so if I apply the contrapositive of number 2, what I will get? I'll get not S imply not W. Not S imply not W. How do I get it? By number 2, contrapositive of 2. Now again you apply 5 and 6 together. What will happen? I have not S imply not W and not W imply H. What I will get from this? I'll get number 7 as not S imply H. Now you see that I know some rules of inference, right? If I have P imply Q and if I have P together, I can extract Q. Right? This is the first rule of inference. So I have not S imply H. So it is like that P imply Q type. So if I somehow get not S, then this one and this one I can, this number 7 and this one if I apply, I can get that conclusion as H. How do I get not S? So this is, I got it. Okay, let me write the reason first. By number 5 and 6. And then I'm saying that I need somehow not of S. How do I get not of S? Yes, from number 1 and simplification, I have not S and C. So I can simply extract that not S by some rule. So by number 1 and the simplification rule of inference. Now I have not S imply H and not S. The first rules of inference, if I apply, I'll get it as conclusion is H. How do I get? By 7 and 8 and by applying the rules of inference 1. I got it. The conclusion is H. We are done. So all these sentences together imply that the conclusion is we'll be home by sunset. We have done it, proved it. Right? So this is one example we have done. Yeah, this one we have already done it. So this is the complete answer, but we already done. Okay, we have one more example. Now you try to do it, make the video pause and you try to do that. Okay, what is given? what are the premises or hypotheses are given, and what is the conclusion. Then you prove it that okay, all these premises lead to this conclusion. So always your job is to represent. If you have a mathematical sentences like this, you try to represent in a with a variable. So I helped you that okay, you represent T by today is Tuesday, M by M is I have a test in mathematics, E by I have a test in economics, and S by my economics professor is sick. Then you understand that what are the things are given as a premises. So the first sentence, number one, it says that if today is Tuesday, I have a test in mathematics or economics. How do you represent? If today is Tuesday, I have a test in mathematics or economics. Right? So it is T imply today is Tuesday imply I have a test in mathematics or economics. So T imply M or E. So this is number one. First premises, first sentence represent that. If today is Tuesday, I have a test in mathematics or economics. Okay, next one. If my economics professor is sick, I will not have a test in economics. How do you represent? If my economics professor is sick, I will not have a test in economics. Yes, it is not S. It is S imply not E. My economics professor is sick. It is represented by S imply not E because I do not have test in economics. So S imply not of E. This is another premises. Number two. Then what is the third sentence? Today is Tuesday and my economics professor is sick. Today is Tuesday and my economics professor is sick. So it means that what it says, today is Tuesday means T and S, my economics professor is sick. So T and S, this is the third premises. So these three are the premises or hypothesis. Then what you have to get it as a conclusion? Therefore, I have a test in mathematics. So what is that thing? Therefore, your conclusion is M. You have to get M from these three. How do you get that? So by applying some rules of inference, you have to get that. So let us see. Okay, so you see where M is involved. M involved only in the first one. Right. So to get M, at least first we can extract that M or E, this part. Now to get this part, I need somehow T so that I can apply rule number one and I can get this, right? But how do I get T? Yes, I can simply apply the third one. So it is T and S is given. So I can get T by simplifying number three. So by three, because T and S is given, so I can individually say for T. This is one of the rule. Then if I have these things now 1 and 4 together, if I apply what I will get? Yes, by rule number 1 and 4 together, if I apply, this is M or E. This is how I got by applying rule number 1 to 1 and 4. So I got M or E. Okay, I have M or E. I have to extract M from this. What I have to do? Somehow if I get not E, I can immediately say E. But how do I get not E? From number 2. But from number 2, I can't get directly. But if I get S, I will get not E. But S, I can immediately get it from number 3. So number 3, I can get S by number 3. Again, simplification of number 3. So I got S. Now 2 and 6 together I am applying. 2 and 6 together. What I will get? It is not of E by 2 and 6 together, right? And by the first rule. Now I have not E and I have M or E. 5 and 7, if I apply, I'll get it as M, right? So by 5 and 7 together, I got it as M. So I got the conclusion is I have a test in mathematics. I'm done. Easy. Right, so you have to practice more like this kind of problem so that because today is the first day we are doing so but if you practice the small rules of inference you have to remember understand and then do practice of this kind of little bit big one you will be like you will understand and you can do it easily. So this part we have already done. Now I have a one more one. So you know that this is that P or Q and not P or R imply Q or R. We already discussed, right? The resolution principle. Resolution. This is the last rules of inference we discussed. Now we have to apply that, and we have to get the solve this example. How do that? So that the premises this and this imply the conclusion as P or S. Okay, let's see. So number one, it is given as P and Q or R. Then number two, it is given as R imply S. These two are the premises given. You have to get P or S. How to do that? How to get that? So I know that the implications law, right? These two are the premises. Let me quickly write. Now I know that implication law P imply Q is equivalent to not P or R. Remember, if we apply that 1 to 2, so I'll get it as not R or S. Not R or S. How do I get it? By the implications law of 2. So R by 2. So we know that R implies is equivalent to not R or S. Implications law. Now I have 1 and 3 together. P and Q or R and then not R or S. Apply the resolution to 1 and 3. What I will get? So R is there and not R is there. This R will get resolved. So I'll get it as P and Q or S by applying resolution to 1 and 3. Now I have applied 1 and 3 and I got this one. Now you apply distributive law to them. So I'll get it as, if I apply distributive law, what will happen? I'll get P or S and Q or S. So distributive law, by applying distributive law to 4, I got this. Okay, now I have this and this. Can't I write it that P or S by simplification law? Right? By number 5, I got this one. It is P or S. We are done. I need to get this to be that. This is the conclusion. We are done. Easy, right? So these things, I am done with this lecture. This is how you can solve that. Okay, you can show that the argument form is valid. So this is the rules of inference and their applications. So I hope you like the video. I hope these videos are helpful. You please write your feedback. If you need any other thing, you can also write it in the comment box. Thank you very much. We'll come up with a new topic in the next video. Thank you. Bye-bye.